Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, this is lesson 18, equations involving a variable expression in the denominator. Okay, so we have a classwork opening exercise. It says, no one says that he checks the answer to divide a problem by performing multiplication. Okay, so he's checking the answer to a division problem by performing multiplication. For example, he says that 20 divided by 4 equals 5 is correct because 5 times 4 equals 20. And 3 divided by a half equals 6 is correct because 6 times 1/2 equals 3. Okay, makes perfect sense. So part A says, using Nolan's reasoning, explain why there is no real number that is the answer to the division problem 5 divided by 0. So if we have 20 divided by 4 equals 5, then he said, well, that's because 5 times 4 equals 20. So they don't have this equal to anything. So if this equaled something, a variable say, then what we're going to do is say some number times 0 equals 5. And there's our reasoning. There is no number such that zero times n equals 5. Okay, there is no number n times 0 that equals 5. All right, part B. Quentin says that 0 divided by 0 equals 17. What do you think? Okay, well, it's true that 0 times 17 equals 0. If you think about 0 over 0, that's anything divided by itself. That should equal 1, so therefore that should equal any number. But again, if we have a 0 in our denominator, we can't have any zeros. So if you have an iPhone, you can ask, I can't say her name because my phone's right here, S-I-R-I. You can ask her what 0 divided by 0 is, and she will give you an answer with regards to cookies and Cookie Monster if you want to try that, if you have an iPhone. Okay? So 0 divided by 0 cannot equal 17. Part C. Mavis says that the expression 5 over x plus 2 has a meaningful value for whatever value one chooses to assign to x. Has a meaningful value for whatever value one chooses to assign for x. So he says that there is a meaningful value for any x. And I would say no, definitely not. So give an example. A meaningful value. So if I put a 5 in here, 5 plus 2 is 7. Well, 5 over 7 is 5/7. That's a meaningful value. Put a 1 in there. 5 over 3 is a meaningful value. Put an 8 in there. 8 plus 2 is 10. 5 over 10 is a half. That has a meaningful value. But if I said x equals -2, then there is no meaningful value. Okay, because 5 over -2 plus 2 equals 5 over 0, and that is undefined. If you put it in your calculator, it'll say error, divide 0, and I'll show you that. So if I turn on my calculator, okay, and I do 5 divide 0, enter, error, divide by 0. Can't do it. Okay? All right, part D. Benoit says that the expression 3x minus 6 over x minus 2 always has the value 3 for whichever value one assigns to it. Do you agree? So what he's saying is if I put a 1 in here, 3 minus 6. So here's what he's saying. Put any number in for x, and you're going to get 3. So 3 times 1 is 3. 3 minus 6 is negative 3. 1 minus 2 is negative 1. That equals 3. Okay? Let's choose a bigger number, 10. 3 times 10 minus 6 over 10 minus 2. 30 minus 6 is 24. 10 minus 2 is 8. 24 divided by 8 is 3. All fine and dandy until you substitute in negative 2, or positive 2. 3. So let me change colors here. So if I put 3 and make x 2 and subtract 6 over 2 minus 2, then I get 3 times 2 is 6. 6 minus 6 is 0. 0 over 0. Okay? That is undefined. That does not equal 3. 0 over 0 does not equal 3. So when x equals 2, our expression does not equal 3. Okay, page 2 brings us to exercise 1 and 2. So here, pause the video, see if you can do these two after me doing that first page, and then come back and check to see if your solutions are correct. So exercise 1 says, rewrite 10 over x plus 5 as a compound statement. So you're going to say, just like it said in the first page, I'll go back. Did it say it anywhere here? No, it didn't. Okay, so compound statement would be, it was in the last lesson, lesson 17. So a compound statement, we did it with inequalities. So you would say something like, let x is greater than 5 or x is less than 2, something like that. So there's two things going on. So I could say 10 over x plus 5 and what's our restriction here? What can x not be? So what makes the denominator 0? So that's what we want. We want to know when this is 0. So over here I'd say x plus 5 equals 0. Subtract 5 from both sides, and we get x equals negative 5. So if x is negative 5 plus 5 is 0. 10 divided by 0 is undefined, so you could say 10 divided by x plus 5 and x cannot equal negative 5. That is your compound statement. Number 2 says, consider x squared minus 25 over x squared minus 9 times x plus 4. Is it permissible to let x equal 5 in this expression? So what they're asking is, can I take this 5, plug it in here, and not get 0? And the answer is yes. 5 plus 4 is 9. Can I take that 5 and plug it in over here and not get 0? 5 squared is 25. 25 minus 9 is not 0. So is it permissible? Yes. So what happens if I do? Well, then that would be 5 squared minus 25 divided by 5 squared minus 9 times 5 plus 4. And that's going to give us, here I can just use an equal sign instead of an arrow. This is going to equal 5 squared is 25 minus 25 divided by 5 squared, which is 25, minus 9, which is 16, times 9. So that's going to equal 25 minus 25 is 0. 16 times 10 is 160. 16 times 9 is 16 less than 160, or 144. So 0 divided by 144 is 0, and that's okay. The numerator can equal 0. The denominator cannot. B says, is it permissible to let x equal 3 in this expression? So again, I look at these two values. So I'm like, okay, we're always focusing on the denominator cannot be 0. So can 3 squared minus 9 equal 0? 9 minus 9 equals 0. 0 equals 0. And it does. So I cannot use 3 in the first parentheses in the denominator, because 0, if this was 3, 3 plus 4 is 7. 0 times 7 is 0. So the answer is no. If I plug the 3 in here, it'd be 9 minus 25. So if I do this like I did here, it'd be 3 squared minus 25 divided by, and I already did this over here, 9 minus 9 times 3 plus 7. So the 9 came from this 3 squared minus 9. 3 squared is 9 minus 25 is a negative 16 over 0 times 10. Well, that's negative 16 over 0. So the answer is no. All right, part C. Give all the values of x that are not permissible in this expression. So I would say x cannot equal 3. X cannot equal what makes this negative, or I'm sorry, what makes this 0, and it'd be negative 4 plus 4, which is 0, so it's negative 4. So the two solutions are 3, negative 4, but you also have to remember a negative squared is positive, so don't forget your x equals negative 3. So let's clean this up and put it in a set notation. So my solutions are negative 4, negative 3, and 3. Okay, page 2 brings us to example 1. So it says, consider the equation 1 over x equals 3 over x minus 2. Okay, so that's a proportion. It says to rewrite the equation into a system of equations. Okay, so you could say, all right, here's a system of equations. One equation is the one that's given, 1 over x equals 3 over x minus 2, and then we just list what x cannot equal. X cannot equal. And on the left side, what would make 1 over x undefined? Well, that may be just x equaling 0. So I'd say 1 over x equals 3 over x minus 2, the given, and x cannot equal 0, and, because there's another fraction, x cannot equal, and what makes this denominator 0? Well, 2 minus 2 is 0, so x cannot equal 2. All right. Part B says, solve the equation for x, excluding those values of x that lead to the denominator of 0. So if I have 1 over x equals 3 over x minus 2, in order to solve this, I can just simply cross multiply because it is a compound. I'm sorry, because it is a proportion. So x times 3, so I'm going to multiply these, and that's going to give me 3x equals, and then I multiply the other direction, these here. Well, 1 times x minus 2 is x minus 2. And getting x is all on one side, I get 2x equals negative 2. Divide by 2, divide by 2, and we get x by itself, and negative 2 divided by positive 2 is negative 1. Okay, so the solution to this is x equals negative 1, and x cannot equal 0, and x cannot equal 2. The solution set is just simply negative 1. You don't list what x can't be in your solution set. Okay, page 3 brings us to example 2. It says, consider the equation x plus 3 over x minus 2 equals 5 over x minus 2. Rewrite the equation into a system of equations. Okay, so we would say x plus 3 divided by x minus 2 equals 5 over x minus 2, and x cannot equal, well, right here, x cannot equal 2. And right here, it's the same denominator, x cannot equal 2 again, so that's it. There's our compound statement. Okay, B says solve the equation for x, excluding the values of x that lead to the denominator of a 0. Alrighty. Alright, so when we have denominators that are the same, we can ignore them because think of this. X over 5 equals 3 over 5. There's a fraction with the same denominator. Well, what does x have to be to make this equal? Well, x has to be 3. 3 over 5 equals 3 over 5, of course. So what I'm saying is you can ignore the denominator when they're the same and just solve the numerator. So x equals 3 would be the solution to making this equal. So with that in mind, since I have a fraction equal to a fraction with the denominators equal, you simply take the numerator of the left, set it equal to the numerator of the right. And when I subtract 3 from both sides, I get x equals 2. But I already said x cannot equal 2. So if I plugged in a 2 here, it'd be 2 plus 3 is 5. 5 over 0 equals 5 over 0. Well, we can't have a fraction with 0 in the denominator, so there is no solution to this. So it's the empty set. So I can represent it as that or an empty bracket. Okay, so now these are exercises 3 through 11. You've tried these yourself. Pause the video, see if you can do them, and come back and see how you did. Okay, so rewrite each equation into a system of equations excluding the values of x that lead to a denominator of 0, then solve the equation for x. So I would say, well, my compound x 5 over x equals 1, and x cannot equal 0. And then it says to solve for it. So if I have 5 over x equals 1 and multiply both sides by x to get it out of the denominator, these cancel and I get 5 equals 1 times x, or simply x, so x equals 5. So my solution set is 5. Okay, number 4. My statement would be 1 over x minus 5 equals 3, and x cannot equal, and what makes this bottom 0? 5. And then solve. 1 over x minus 5 equals 3. Think of that as 3 over 1. Cross multiply, so I'd get 3 times x minus 5 equals 1 times 1, which is 1. So 3x minus 15, distributing that 3 equals 1. Add 15 to both sides. 3x equals 1 plus 15, or 16. Divide by 3, and x equals 16 thirds. So my solution to this is 16 over 3. Number 5. My compound would be x over x plus 1 equals 4, and x cannot equal negative 1. Solving by cross multiplying. Think of that as 4 over 1. Cross multiply, 1 times x is x, 4 times x plus 1 is 4x plus 4 equals x. Subtract x over to here, so I'll do that over here. 4x minus x is 3x plus 4 equals 0. Subtract 4 over to the other side, and I get 3x equals negative 4. Divide both sides by 3, and x equals negative 4 thirds. Bracket, negative 4 over 3. Okay, number 6. 2 over x equals 3 over x minus 4, and x cannot equal 0, and x cannot equal 4 minus 4 is 0, so x cannot equal 4. And when I'm going to speed this up a little, I'm just going to cross multiply. 3 times x is 3x equals 2 times x minus 4, distributing 2 times x is 2x, minus 2 times 4 is 8. Subtract 2x from both sides, and I get x equals negative 8. It's not one of my zeros, always check that. Put a negative 8 in. That is my solution. Number 7. Here, let me fix this page first. Okay, get all that stuff out of the way so we can focus on this. So my compound in this one, I'll do it off to the side here. X over x plus 6 equals negative x, or 6 over x plus 6, and x cannot equal And if I look at this side, -6, this denominator is the same. That can't be -6 either, so it's -6. So when I solve this, remember what we said. When the denominators are the same, we can just take the numerators and set them equal. So we have x equals -6, just looking at this top right here. Well, we already said x cannot equal -6, so there's no solution. So I can do this, or that also means no solution. All right, this one, compound statement, x minus 3 divided by x plus 2 equals 0, and x cannot equal, the denominator being 0 would happen when x is -2. Now solving this, again, this is x minus 3 over x plus 2 equals 0 over 1, right? And 0 divided by 1 is 0. So in order to solve this, I would cross multiply. Well, keep in mind, though, we don't even have to do that. When you have a fraction, the numerator is 0. Then the whole thing is 0. So all I have to do is set the numerator equal to 0. And when I do that, we get the value for x. So 3 minus 3 is 0. 3 plus 2 is 5. 0 over 5 is 0. So the solution to this is 3. It's not my restriction. We're all good. Okay, page 4 brings us to number 9. Let me just move this up a little bit. So my compound here would be x plus 3 over x plus 3 equals 5, and x cannot equal, what makes that 0? -3. Okay, now let's solve this thing. X plus 3 over x plus 3 equals 5 over 1. Cross multiply. 5x plus 15 equals, x plus 3 times 1 is just x plus 3. Subtract x from both sides, I get 4x. Subtract 15 from both sides, I get -12. Right? 3 minus 15 is -12. Divide both sides by 4. I get x equals -3. Whoops. No solution. The only value that makes this numerator, or makes this equal to 5, is -3. -3 plus 3 is 0. -3 plus 3 is 0. 0 over 0 does not equal 5. So there is no solution. Number 10. Compound statement, x plus 3 over x plus 3 equals 1, and x cannot equal -3. Then we go and solve it. X plus 3 over x plus 3 equals 1 over 1. Cross multiply. X plus 3 equals x plus 3, right? X plus 3 times 1. 1 times x plus 3. Subtract x from both sides, and I get 3 equals 3. The solution set is the set of all real numbers except x equals -3. Don't forget that right there. So all real numbers. So on the number line, be everything except an open circle at -3. Okay, number 11. A baseball player's batting average is calculated by dividing the number of times the player got to hit, number of times at bat, by the total number of times the player was at, number of times the player got a hit by the total number of times the player was at bat. Okay, so it is expressed as a decimal rounded to 3 places. After the first 10 games of the season, Samuel had 12 hits off of 33 at-bats. What is his batting average after 10 first games? Okay, well, it is dividing the number of times the player got a hit, 12 hits, by the total number of times the player was at bat. He was at bat 33 times. Okay. We could do this with a calculator. Long division. Either way, I'll just use the calculator to save time here. So it's 12 divided by 33 equals, and that is an approximation, 0.363. 6. Okay, right? It's just repeating 36363636. All right. So this says round 3 places right here. Let me highlight that. Always read your directions. Round to 3 decimal places. All right. So where's my pen? I'm going to fix this. 3.3636. The 6 will make that last 3.364 because it's more than 5. Part B. How many hits in a row would he need to get to raise his batting average above 500? Okay, so what you want to do here, you could guess and check all day long by going 13 over 34, 14 out of 35, 15 out of 36, and so on and so on and so on. But this is algebra, so we're going to set up an algebraic equation, or inequality, if you will, in this case. So we're going to take, he's already gotten 12 hits, plus some other number of hits divided by 33 plus some unknown number of hits where they're going to be equal. In other words, he's got to get a hit every time next at bat until we find out when he's batting 500. So that has to be greater than, because it says to raise his batting average to above 0.5 or 500. So that's got to be greater than 0.500. Okay? So in order to do this, we're going to set up an equal. We're going to do it with equals. 12 plus x over 33 plus x equals 1/2, because that's 0.5. Cross multiply, and I get 33 plus x equals 12 times 2, 24 plus 2x. Subtract x from both sides, and I get 33 equals 24 plus x. Subtract 24 from both sides, and I ran out of room. X is going to equal 33 minus 24 is 9. So my answer is x is greater than 9. So he would need 10 hits in a row to be above 500. Okay, so you could write that. He would need 10 hits in a row to get above 500. Okay, part C. How many at-bats in a row would a hit result in a batting average dropping below 300? Okay, so now it's the same, except we're going to be less than 300. Okay, so this one we have to think a little differently. This one would be, we already have 12 at-bats, but if we want our batting average to go down, we're going to not get a hit. So, actually, we've had 33 at-bats, 12 hits. We don't want to get any more hits, so don't say 12 plus x. We're just going to leave that 12. No more hits, but we're going to increase the number of times at-bat. So that was the trick to this part. And less than 0.300. Okay. So in order to solve this, it'd be 12 over 33 plus x equals, well, that's 1/3, 3/10, if you will. Cross multiply, and I get 36 equals 33 plus x. Subtract 33, and I get 3 equals x. Oops, I'm sorry, I made a mistake. It's not 1/3. 0.3 repeating is 1/3. I have 0.3. That's 3/10. My apologies. 3/10. Cross multiply this, and I'd get 99 plus x equals 12 times 10, or 120. Subtract 99 from both sides, and that would be x equals 21. Okay, that didn't make sense to me, so I'm saying, okay, what happened here? Well, here's what happened. I am scrambling around here. I'm at the end of my video and I'm making mistakes. I didn't distribute properly. 3 times 33 is 99. 3 times x is 3x equals 120. Now subtract 99. My apologies for this error, but we got it. Now I get 21, which I had, but I need to divide by 3, and that would give me x equals 7. So the answer is x is greater than 7 at bats. So if he went to bat 8 more times without a hit, his average would drop below 300. Okay, page 5 brings us to the end of lesson 18. Go do your problem set.